In this lesson, we're going to learn how to load a dimension table in a data warehouse. This lesson assumes that you know the basics of data warehousing already, namely what a dimension table is and a fact table is. To load this dimension table, we're going to use this thing called a slowly changing dimension wizard, which can be found in your data flow tab. You'll simply drag over your source, drag over any kind of components that are going to flatten the tables, and then you'll connect it to the slowly changing dimension wizard. By doing this, it'll ask you a number of questions. The first question is going to be, is the type 0, 1, or 2 dimension? And this is a column by column decision. A type 0 change is a column that cannot be changed. This column has two options. Either the change will cause a failure, or a change that comes in during a type 2 column will be ignored. A type 1 column will basically overwrite the history. So we're not going to keep track of any history. It's called a changing attribute. So if a number changes from address line 1 column from apartment A to apartment B, you won't keep track of any history. Lastly, type 2 columns are historical changes, meaning that if I move from apartment A to apartment B, I will create another row and expire the old row. The last bit of terminology is the inferred member. An inferred member is also called a late arriving fact. And this is when you have a row coming in that has no member in the dimension table. This usually happens during the fact table. So in order to not trigger a type 2 update, you would simply update all of the stub record information with known information. And I'll show you what I mean in a moment here. So now that we have the core information about what this wizard can do, let's try it. So to do this lesson, you'll need to first create a table called product dimension table. This is done through Lesson47 createtable.sql, which you can download from the ROCS website. After then, you want to load this product dimension table from the production.product table, which can be found on the AdventureWorks 2008 database. The list price column should be a type 2 dimension column. The other column should be type 1. The only additional thing you'll want to do is have a derived column transform, which will translate the color column, if it's null, to unknown. Not doing that will generate an error. So I'm going to start by creating a new package inside the Business Intelligence Development Studio environment. I'll first create a new OLEDB connection to the AdventureWorks database. And at this point, you know how to create these OLEDB connections. And I'll also create one to the AdventureWorks DW database. Again, at this point, we're assuming you already know how to do that piece. I'm then going to open up Management Studio to run the script. This script can be downloaded from the ROCS website, and you want to run this against the AdventureWorks DW database. Once you locate the file, go ahead and run this against the AdventureWorks 2008 database, DW database, which is going to create a product dimension. It also creates a product key, which is identity column, and that is the circuit key for the table. The product alternate key is the business key for the table. Next, create a data flow task. And in the data flow task, let's drag over an OLEDB source. This OLEDB source should point to the AdventureWorks database, and I'm going to point to the production.product table. And hit OK. We next need a derived column transform, which is going to protect us from null data. Keep in mind, I'm not naming these components properly, but you get the idea. So let's drag over. We want to make sure the color property is properly named. So I'll drag down color, and inside of color, I want to check to see if it's null. If it's null, well, let's convert that with that to a unknown. Else, keep the color column. By dragging and dropping it one more time. And we're going to replace the color column. So essentially what this is saying is if the color is null, that question mark is a then statement, put the value of unknown. Else is the colon, keep the existing color. Hit OK, and our color is now taken care of. Our next step is to drag a slowly changing dimension transform over. Let's drag that over, wire it up, and when you double click on that transform, it opens up the slowly changing dimension wizard. Select Next, point to which database you want to load, and from the drop-down box, pick the table you want to load. In our case, it is the product dimension. Now, there are a few columns here that don't exactly match up here, so we need to fix those problems now. The first thing to note is our product alternate key. Well, that's actually called product number, and that is our business key. Our product name, well, that's the name column. Hit Next, and you want to pick each column and whether it's type 1 or type 2 change, or type 0. I'm going to do Tab C a few times to get everything down here, and then change the list price to a historical attribute, or type 2. Check the changing attributes column, select Next, and now we need to specify how is a column going to be expired before it is created. So how are we going to expire for that type 2 change that we had back there? How are we going to expire the row and create another row? So I'm going to select that start date and date, and these are two columns here that exist on the destinations table. So these two columns here are in that prospect table. If you notice down here, if I go all the way to the very bottom, I have a start date, end date column. So it's not pulling those out of thin air, it actually pulled those from that column there. I now need to specify which variable do I want to set that to. Well, I'm going to set it to the time this task started. These are 3 date variables that it found. I can also have my own user variable there. You can also customize the code later. I'll select Next, and this table is not going to have inferred numbers. Select Next again, and then Finish. So let's look at the changes as they go through here. So let's start by first selecting against the table, just to see what we're getting into. As you can see, there are no rows. Let's load some rows into it. So first, as you can see, it's created a lot of code for us. Type 1 changes are going to go this way. New records will go down this output here, where they're first merged in with their outputs. A start date is assigned, and then they're inserted into the destination. For optimization, I'm also going to turn on fast load, and I'm going to uncheck the table lock. Next, type 2 changes, or historical changes, are going to go this way, where they're first expired, and the date is assigned, then they're expired with the OLEDB command transform, then they arrive this way for later load. Let's run this now. So all of our rows the first time should go straight down there at 504 rows. So what's happening here is all 504 rows hit this slowly changing dimension wizard transform. At that point, every row is then evaluated to see if it's a new row, a type 1 change over here, a type 2 change to your right, or a duplicate. Notice I have other green lines here, so there are duplicates here. You can customize a lot of this code. You can also go through and change the exact, rather than do end date of null, you can make that any end date you want to, including like 2099 or some arbitrary date in the future. So let's make some changes. Now that I have this done, I'm going to make some changes here that will affect our dimension. So I'm going to open up the second file here, which is the 47 changes here. Make a few changes here. Okay. So as you can see, this is the row that we just made a change to on the source system. Now it hasn't changed the destination here. So I made a type 2 change, I changed its list price. So let's watch what happens. So if I execute this again, as you can see, one row went down that way and was later written to the destination. If I run this again, you'll see I have 2 rows. One has been expired, and one is brand new, end date of null. So for any future records that I'm inserting to the fact table, I'll insert product key 505, not product key 4, for this one product. And a few things to be concerned about here. The OLEDB command transform, first of all, which is this guy right here, and you'll also see one over here as well. These two transforms do not scale very well. They do a row by row update. So if I'm setting 50,000 rows over here to be updated, then row by row, all 50,000 rows will be updated, which can take some time. Additionally, this is going to select row by row here to make sure of what bucket the data goes into. That can also take some time and maybe haphazardly. So you want to make sure that no more than about 50,000 rows go into this. The last thing is, notice you can open up this wizard and run through it all over again and make some small changes. If you make changes, the very end, if I hit finish, it actually is going to drop all these components and recreate them. So if I've done any kind of customization to any of these components here, all that customization would soon be dropped and recreated. So it's a good idea to document exactly how you did this. In this lesson, we learned how to load a slowly changing dimension by using a slowly changing dimension wizard inside of SSIS. There are some scalability issues, as we talked about, for large data sets. Additionally, there are some maintainability issues. So if I run the wizard again, it's going to drop all and recreate all the components. So be careful when you customize this. This is not the only way you have to load the slowly changing dimensions. However, it is definitely the easiest way to load them. Now that we know about how to load a dimension, let's now talk about how to load a fact table.